Hello all. In today's class, we are going to see the various rules followed by these rays of light while coming and hitting spherical mirrors. First of all, let's take the case of concave mirror. As you can see, now I am standing on the principal axis of this concave mirror. The first rule is, whenever a ray of light, as you can see on top of me, whenever a ray of light parallel to the principal axis, you can see both of these are parallel. The ray is parallel to the principal axis. So whenever a ray of light parallel to the principal axis comes and hits the concave mirror, the reflected ray will go back through the focus. So whenever a ray of light parallel to the principal axis comes and hits the mirror, the reflected ray will go back through the focus. The opposite also will happen. I'll show you now. Whenever a ray of light comes through the focus, it will hit the concave mirror and gets reflected back parallel to the principal axis. So, suppose if a ray of light is coming parallel to the principal axis, it will go through the focus, and if a ray of light is coming through the focus, it will go parallel to the principal axis. Easy. Next rule is very important for us, and it is connected with this center of curvature. We know that any line drawn from this center of curvature to anywhere on this aperture of the mirror is a normal to the mirror. In simple terms, it means that if you draw any line from the center of curvature to the aperture, it can be a line like this, line like this, line like this. So all these lines, when it goes and hits the mirror, it will form 90-degree angle there on the mirror, which means any line drawn from the center of curvature to the mirror is a normal to the mirror. So even in plane mirror, we have studied that as per the laws of reflection of light, any light passing through the normal will come back through the normal. So now, whenever a ray of light passes through the center of curvature like this, it will hit and come back through the center of curvature. So any ray of light which is going through the center of curvature will come back through the same path. The next rule is, if a ray of light comes and hits the pole, it will just get reflected back following the laws of reflection of light. Now, the ray of light is hitting at the pole, and I have the principal axis here. So, on top of the principal axis and at the bottom of the principal axis, equal angles will be made. Suppose, if this ray is coming and hitting at an angle of 30 degree, making an angle of 30 degree with the principal axis, then the reflected ray also will make 30 degree with the principal axis. That's all. Now let's see what happens in the case of convex mirror. The laws are exactly same as in the case of concave mirror. Only difference is, here the points like the principal focus, the center of curvature, everything comes inside the mirror or behind the mirror. In the case of concave mirror, all these points are in front of the reflecting surface. So here, when a ray of light comes parallel to the principal axis, it will get reflected back from the mirror in such a way that the ray, when we extend it inside the mirror, seems like it's coming from the focus of the mirror. So the law is basically same. If a ray of light comes parallel to the principal axis, it will go striking the focus. But here, in the case of convex mirror, the ray can't directly come and hit the focus because it's inside the mirror. So it will just reflect back, but if we extend it inside the mirror, we'll feel like it's coming from the focus. So a ray of light parallel to the principal axis will go through the focus, or it will seem like it's coming from the focus. So even the opposite can happen. If a ray of light is coming and hitting the focus, which is practically not possible, but if a ray of light seems like it's coming and hitting the focus, it will go parallel to the principal axis. Opposite also happens. Look here. Here, the ray of light seems like it's coming and hitting the focus. It can't directly come and hit the focus. It's practically impossible because the focus is inside the mirror. But it seems like the ray of light is coming and hitting the focus. In that case, after hitting the mirror there, the ray will reflect back parallel to the principal axis. So, if a ray of light seems like it's coming to the focus, it will go parallel to the principal axis. If a ray of light is coming parallel to the principal axis, it will just get reflected back in such a way that it seems like it's coming to the focus. That's all. The next rule is, looking from here, if we feel like that ray of light is coming towards the center of curvature, then it will just get reflected back. Because as we told earlier, a line drawn from the center of curvature to anywhere on this mirror is a normal. So, a ray of light coming through the normal will get reflected back through the normal itself. So, a ray of light which seems like it's coming and hitting the center of curvature will go back through the same path. That's the next rule. In the case of convex mirror also, if a ray of light comes and hits the pole, it will just get reflected back following the laws of reflection of light, making equal angles on top of the principal axis and at the bottom of the principal axis. Let's revise all the rules once again. A ray parallel to the principal axis will go through the focus. A ray coming through the focus will go parallel to the principal axis. A ray coming through the center of curvature will go back through the center of curvature. The ray which hits the pole will go back, making equal angles on both the sides of the principal axis, following laws of reflection of light. In convex mirror, the rules are same, but whatever happens inside seems like it's happening. That's all. So, a ray of light coming parallel to the principal axis seems like it's coming from the focus. A ray of light which seems like coming and hitting the focus will go parallel to the principal axis. The ray of light which seems coming and hitting the center of curvature will go back through the center of curvature itself. And finally, if a ray of light comes and hits the pole, it will just get reflected back, making equal angles on top and bottom of the principal axis. Now, using these laws, we are going to study how image is formed in spherical mirrors. We'll discuss about this in next class.